Good day everyone, I am Catherine Santiago from BSc 4A and I'm going to talk about collapse mechanism. Collapse mechanism is the arrangement of plastic and real hinges which permit collapse in the structure, or it is a kinematic mechanism permitting an unbounded displacement of the system that can be formed by inserting a plastic hinge at a plastic limit load into a statically determinate beam. For each degree of static indeterminacy of the beam, an additional plastic hinge must be added to form a collapse mechanism. It is used in structural analysis and design. The formation of a single plastic hinge gives a collapse mechanism for a simply supported beam. Collapse occurs when there is no remaining stable element that can carry the additional load. So, identify naman natin sa figure ng statically determinate and indeterminate beam yung mga real and plastic hinges. For a statically determinate beam, it will fail if one plastic hinge is developed. Consider the simple supported beam that has a constant cross-section and is loaded with a concentrated load P at midspan. Di ba pag sinabi nating hinge, hindi siya nagre-resist ng moment. So dito, yung real hinges ay manggagaling sa support. Pag hindi nagre-resist ng moment, considered siya as real hinge. If P is increased until a plastic hinge is developed at the point of maximum moment, just underneath P, an unstable structure will be created as shown in this figure. Any further increase in the load will cause a collapse. Then, itong P sub n nagre-represent ng nominal or theoretical maximum load that the beam can support. For a statically indeterminate beam to fail, more than one plastic hinge must form. The number of plastic hinge required for failure of a statically indeterminate structure will be shown to vary from structure to structure, but never be less than 2. The fixed end beam in this figure can fail unless the 3 hinges shown in the figure are developed, the 3 plastic hinges. Although a plastic hinge may be formed in a statically indeterminate structure, the load can still be increased without causing failure into the geometry of the structure is preserved. So, yung plastic hinge will act like a real hinge as far as the increased loading is concerned. As the load is increased, there is a redistribution of moment because of the plastic hinge can resist no more moment. As more plastic hinges are formed in the structure, there will eventually be a sufficient number of them to cause the collapse. Actually, some additional load can be carried after this time before collapse occurs as the stresses go into the strain hardening range. However, yung deflections that would occur are too large to be permissible in the design. So, sa plastic analysis, i-apply natin yung virtual work method wherein the work performed by the external loads during this displacement is equated to the internal work absorbed by the hinges. So, ang magiging equation natin is external work is equals to internal work. For this case, the small angle theory is used. The sine of a small angle equals the tangent of that angle and also equals the same angle expressed in radians. So, dito, meron tayong figure na fixed-ended beam na may distributed load na W sub n. Ang maximum moment natin is nasa midspan. So, paano ba natin masasolve dito yung plastic limit or nominal distributed load, W sub n, in terms of the plastic or nominal moment, M sub n, developed at the hinges. So, external work is equals to total external load times the deflection of mechanism. So, yung total external load natin is equals to W sub n times length. So, paano naman sa deflection? So makikita natin dito sa figure na nasa midspan yung maximum moment. So L over 2 lang dito, hatiin lang yung length sa dalawa. Therefore, dito yung plastic hinge natin. Dito yung mabubuong plastic hinge. May angle theta tayo dito. Since equal length lang naman, theta rin to. Same lang siya ng height dito. So mapo-form natin na right triangle. Let's say na y yung deflection natin. So magagamit natin si tangent. So tangent theta is equals to opposite na y, na ito yung deflection natin, all over adjacent side na L over 2. Diba sabi sa small angle theory, yung sine of a small angle is equal sa tangent of that angle and also equals the same angle expressed in radians. So, theta is equal sa deflection natin all over L over 2. So, masasolve natin yung deflections as theta L over 2. For distributed load, dito, only 1/2 ng deflection lang. So, 1/2 theta L over 2 yung ginagamit pag distributed load. Pag concentrated load naman, full deflection. So, para sa figure natin na to, yung W external or work external is equals to W sub NL times 1/2 ng deflection na theta L over 2. So, internal work is the sum of M sub N at each plastic hinge times the angle through which it works. So, yung M sub N natin is equals to M sub B or the plastic moment. So, dito, ang ilalagay lang natin na angle is kung saan may plastic hinge. Since plastic hinge to, ito and ito, may theta tayo, theta ulit, and 2 theta. So, internal work is equals to M sub B times theta plus 2 theta plus theta. So, internal work is equals to external work, M sub P times theta plus 2 theta plus theta is equals to W sub NL times 1/2 ng deflection. So, M sub P is equals to W sub NL squared over 16, or kung W sub N naman yung kinukuha natin, is equals to 16 M sub B over L squared. Pag dito lang sa fixed-ended beam na may concentrated load. Sample problem 1. A fixed-ended structural steel beam is used to carry a uniform intimate load distributed throughout its span. The beam has a span of 6 meters and has a plastic moment capacity M sub B is equals to 500 kilonewton meter. Which of the following gives the uniform load it can carry at the collapse load? So, ito po yung figure ng fixed-ended beam natin na may 6 meter at concentrated load na W sub U. So, proceed na po tayo sa solution. So, may figure po tayo dito para mas madaling ma-identify. Ito lang rin po yung inanalyze natin kanina. May given na length lang po tayo na 6 meter at plastic moment na 500 kilonewton meter. So, gagamitin lang po natin dito yung virtual work method. So, internal work is equals to external work. Plastic moment times natin yung sa mga angle na may plastic hinges. So, M sub B times theta plus 2 theta plus theta, since etong tatlo na to is plastic hinges. Is equals to W sub U times length times 1/2 ng deflection. So, bakit 1/2? Kasi distributed load. substitute natin yung mga given. So, m sub p is equals to 500 times 4 theta is equals to 0.5 w sub u times the length na 6 meter. Then, theta times all over 2 na 6 over 2. So, 2,000 theta is equals to 9 theta w sub u. Solving for w sub u is equals to 222.22 kilonewton meter. Pag kabisado natin yung naging equation natin kanina na w sub u is equals to 16 m sub p over L squared, pag fixed-ended beam na may distributed load, substitute na lang natin yung given na length and plastic moment. So, next problem po. For the prop beam shown, determine the plastic limit or nominal load P sub n in the terms of plastic or nominal moment M sub n developed at the hinges. So, yung P sub n natin, makikita natin sa figure na nasa midspan siya. So, ito po yung figure ng collapse mechanism. Because of the symmetry, L over 2 and L over 2, the rotation theta at the ends of the plastic hinges are equal. So, plastic hinges at the end of this is theta and dito din theta. The work done by the external load is equals to P sub n times the deflection y of the mechanism at the center of the beam. So, the internal work absorbed by the hinges is equals to the sum of plastic moments M sub n at each plastic hinges times the angle through which it works. Take note that in this example, we only have 2 plastic hinges. And this point of the mechanism. So this point is a real hinge and no moment occurs at this point. So external work is equals to internal work. P sub n times the deflection na theta L over 2. Since concentrated load siya, hindi na natin siya ita-times sa 1/2. Then, it is equals to m sub n times theta plus 2 theta kung saan may plastic hinge. Solving for P sub n is equals to 6 m sub n over L. That's all. Thank you.